Okay, let's start. Okay, so how is the quiz? Huh? Everyone get 100, no? Yeah, you're supposed to use the number of attempts. Okay. Anyway, okay, let's start with uh, our lecture today. So what is the agenda? Okay, welcome back to plan 258, right? Okay. Agenda for today is the quiz. We've done that. Okay, 10-minute quiz. Okay, and let's discuss our first lecture about application guides, and then I hope you can share your assignment, okay, on power dynamics this week. Okay? And then we will go to the next topic, about prioritization and multi-criteria decision making. Okay. Okay, let's do that. Our first lecture is about application of IFN. You can follow this in Moodle. Can you see my screen?
Yes, Doc, we can see.
Okay. Right. Okay. Uh, this slide is also in Moodle, so you can download. Okay. It's only 30 slides. Anyway, so it based on the Bible. This is the Ecclesiastes. It's basically talking about the cycle, yeah, in our life. So I want to discuss two things. Yeah, what is IFN, which is to model the ideal condition, and 5 steps. Yeah? Let's call this SCAIs, okay, of application guides. So first topic is about IFN. So when we said ideal flow network or IFN, okay, it is a model to represent the ideal condition. So let's say ideal is something story in heaven. Yeah? Something probably is difficult to reach, but through IFN, we show that the ideal things are within our reach. So again, it's a biblical context based on this Colossians 3 verses 2. Okay, so why do we want to model the ideal condition? That's the first question, right? So because the ideal condition will give us the goal. Okay, so to be effective is actually much more important than to be efficient, isn't it? So, but to be effective, you need to know the goal. Okay? So IFN will give you some ideal condition, which is the goal. So once we know the goal, then we know the direction toward the goal. Okay. So because of IFN, so we can start to see what's the heaven in the code that we can reach within our graphs. Okay. Then we can say that if we don't reach our goal at this point of time, okay, at this moment, we did not reach the goal yet. It is okay, right? So we know, if we know that we continue in this direction, okay, because we know the goal, right? So if we continue in this direction toward the goal, okay, we will eventually reach the goal. So the FN analysis will give us kind of compass, okay, on various views, okay, about what is the ideal condition, so that we can navigate in our decision, in our policies, in our society. Okay, so again, IFN analysis is just tool with that will help us to find the efficient way toward reaching our goal. Okay, whatever goal it is that you set. Okay, so now I propose 5 steps. Yeah, so let's call this SCAI IS. So number one is set the context of your application. And then you create the IFN. Yeah? C means you create the IFN. And then you analyze the IFN. Okay? And then you interpret back to the context. And the last one is to share your insight with others. Okay. So let's go back. Let's go to the first step. Yeah. First, you need to identify what is the specific area where the IFN will be applied. Of course, you need to understand the background, your objective, maybe your limitation, okay, certain assumption that you need. So you may want to gather relevant information and data. Okay. If you don't have data, you can assume. Okay. To form the foundation for the IFN. Okay. After that, you create a contextual representation. That means what is the meaning of node? What is the meaning of links? And what is the meaning of the flow? Yeah? Node probably represents some agent, probably represents some factors or certain intersection and so on. So the links may represent certain influence or information or control or certain feedbacks, or the links represent the road. Okay? So it is you who give the contextual representation. Okay. After that, of course, you make it irreducible. Okay. So the context of each element, okay, you need to map out the meaning of various IFN elements. In this case, was the node, the links, and the flow. That's the most important context. Okay, what is the meaning of nodes here? Oh, nodes is the state, or node is the event, or node is the agent or factor, probably certain strategy. So you are the one who decide the meaning of node. Okay. Second, you decide the meaning of links. Okay. Mathematically, this is just directional connection, but you are the one who decide the meaning. Okay. And then the flow is representing the values on the link. So the point is you need to ensure, okay, that the network will be strongly connected, okay, irreducible. Yeah. This can be done by adding or removing the nodes or the links, or changing the link direction, or probably adding certain cloud node. So here are the alternative. Yeah. So the element interpretation of what is the meaning of node, links, and flow. Okay, I give you several lists here. So node can represent people, agent, probably entity, certain groups, okay, certain place or items, okay, probably the intersection in the road. Okay, this is my favorite. Yeah. So if you think use system dynamic or system thinking, okay, node is actually a level or the state of system. Okay, so this represents the position, the event, okay, the moment of choice in time and space, probably certain factor or decision point, basically. Okay, now the link itself, again, you can interpret links as influence, maybe just association. Okay, the most important is link actually represent the change. Okay, change in the system or the rate in the system dynamic. Okay? So link represent action, certain transformation, maybe function, yeah, certain velocity, yeah, or branching of alternative choices in your life at certain moment. Okay? If the node represent the point in moment in time and space, then of course the link represent the alternative of choice. Okay, then what is the meaning of flow? Yeah, flow is something that we share. Okay, so maybe flow represents certain action, certain things that you give or share, certain consequence. Okay, or certain resources, probably money, maybe energy, maybe just a message. Okay, and flow can be strength of influence. Okay, in terms of time, power. So probability and so on. Probably represent the goods. Yeah. Or you can represent this as intangible items. For example, the kind of help to others or certain kindness to others. Okay. So again, the interpretation depends on you who model. Okay. So once you create the IFN, practically the network, okay, then you need to ensure that this network is strongly connected. Yeah, because IFN can only be analyzed when your network is strongly connected. That is why you always check the irreducibility condition first. Okay, so a strongly connected network represents integration. Okay, having check and balance in the system. That means every pair of the cycle inside, there's at least one pivot. Okay? Now, if you think about in the philosophical terms, so strongly connected network represent universal interdependency. Okay, it means that we are part of the bigger system than ourselves. So no one can stand alone in the community or the society. Okay, mathematically, it's just about connectedness. So if we go in the transport network, we goes anywhere, we must be able to go home, right? So this is the meaning of strongly connected network. Yeah. So the second step is once you create a strongly connected network, then you create the IFN. Yeah. So this is where the software can help, right? So to compute the IFN, yeah. So you can set up the node and links, and then ensure strongly connected. After that, you can have many ways to create the IFN. Yeah, either maybe using the capacity matrix or based on stochastic matrix. Okay, or maybe based on signature, or maybe based on random walk or random cycle, and so on. So the way you compute the IFN, the way you calculate the IFN, there are many ways to do. Okay, we have discussed a few of them, right? So you already did from capacity to stochastic, and then directly to ideal flow. And last meeting we discussed about network signature, where you can also merge and assign. Yeah. Of course, we can also do a random walk and random cycle if you want. Okay. So once you create the IFN, so what you will do is to analyze that IFN. Yeah. So again, once you created the IFN, again, many ways to analyze. Yeah. One is to do what if scenario. Okay. So this means you have some policy that you want to apply. The policy represents the change. Okay. That change can be in the network structure or in the link strength. Okay. So after that, you can also do cycle analysis. So you identify the cycles, okay, how many it repeated, and then you analyze the pivot. Okay. Or you can do what is called Markov analysis. So we get the node distribution. Okay. So the sum of row and the sum of columns of ideal flow matrix represent the node distribution. Or you can go directly in the links. Yeah? That means in the matrix, you can see the links, the positive values that represent the probability. Okay. And we have discussed about premium network and cardinal network. So that represent the power dynamics. Yeah. Well, alternatively, I did not discuss this in our course. So we can also do what is called a clustering, hierarchical component based on analysis and many other analysis, yeah, including the supervised and unsupervised learning and so on. Okay. So for our course, probably what is important for you is policy analysis. Okay, policy means change. Okay, what is the change? Change in network structure on change in the capacity. Okay, so using this now you can predict and control. Yeah, by analyzing the structural change or the value change. Okay, so in that case, borrowing the term from chemistry, we have atoms, right? And then on top of the atoms, when a few atoms combine, we can create what is called molecule. Yeah. So atomic policy means you can add or remove the nodes. Okay. Again, you can need to come back. What's the meaning of the node? Yeah? So and then you can also add or removing the links. Okay. Or you can edit the strength capacity of the links. So these are atomic policy. Yeah? So then when you combine several policies together, this is called molecular policies. Yeah? So you can, for example, if you want to change the link direction, so from left to right to left, that's the same as removing and then you add the link, isn't it? So that means two atomic policy you combine into molecular policies. Okay, so the key aspect here is what will happen. Yeah, is what if analysis. So what will happen if we change the network structure? What will happen if we change the influence strength or the capacity? Okay, so this change in the network structure or capacity is called policy. Okay, so once you create the analysis, okay, so then it's time to interpret. Yeah, interpret back to the original context in the first step. Okay, so you need to recall the goal and the objective in the analysis. Yeah, and then you assess the impact on that goal. Okay, and then you determine, okay, what is the practical implication, okay, for your own decision. Okay, so additionally, if you want, you can seek deeper meaning. Yeah, what is the philosophical or spiritual understanding on this matter? Okay, or optionally, you can also expand, yeah, the context, yeah, beyond the original goal. So you can interpret or reinterpret in different disciplines or in other fields as well. Okay, so one way, okay, is to think in terms of cycle and pivot. So this is what you did not make yet. So I hope you can continue what you are doing in your homework yesterday that you submitted, okay, into cycles and pivot. Yeah, you in IFN Excel add-ins, that is, you just put n underscore all cycles, so you can get, or n pivot, so you can get also the pivot. So a cycle is basically a round trip, okay, that represent the consequential decision or recurrent pattern of the event in the time or space. Okay, so cycle, okay, represent the logical consequence that eventually come back to us. Okay, so what move out inevitably will return. Okay, but the points in here is now you can start to measure and you start to see the balance in the system. Okay, so this is cause and effect in the system. So it's similar to karma concept. Okay, using this cycle analysis, now you can start to think holistically. Yeah, integrity, yeah, and responsibility. Okay, now if you have several cycles, okay, then any pair of cycles usually will have pivot. Okay? Otherwise, it is not irreducible. Yeah? So if you have irreducible or strongly connected, not each pair, but any pair of cycle, usually you will get pivot. So pivot is basically overlapping part between cycles, okay? Where you're being together, maybe share events, maybe common point of interest, okay? Maybe if this is decision point, that means joint decision, yeah? In time or in space or in both time and space, okay? So knowing all of this, now you can start to interpret, yeah? What is the meaning of cycle here? What is the meaning of pivot here? Okay. And then you can also interpret the whole system. Okay. Once you create the IFN, now you can start to interpret the whole system. Okay. That means what is the meaning of irreducibility here? Yeah. The strongly connected here. Okay. The whole, yeah, of the system itself. Okay. Of course, IFN is pragmatic, irreducible. So then you ask, what is the meaning of pragmatic? What is the meaning of irreducible in your context? of your application. Right? So here I provide the usual interpretation. Okay, the connectivity represent whole thing, yeah, integrity. Okay, or we are united. Okay, so and then or complete system, okay? Unbreakable system. So pragmatic means balance, fairness, reciprocity, yeah, and there is no overloaded nodes. Yeah, these are the usual interpretation, but you can try to find the context interpretation within your application. Okay, and if you use cloud node, okay, then you need to interpret what's the meaning of this. Yeah. Okay, so in IFN there is a theorem said that we only need one cloud node. Yeah, is necessary and sufficient for all systems. That means if we can represent something outside of our system, yeah, metaphorically, the cloud node represent that. Yeah, so the dummy links represent the players. Okay, that means if you create this spiritual interpretation, the connected network represent an entity, then that means if you're weak, you can be strong by connecting yourself to the cloud, yeah, via dummy links or the players. Yeah. Okay, and the cloud node itself is actually in the higher layer that connect all the other nodes. That means they are connecting all the layers. Yeah? Interpretation is God is everywhere in all reality. And don't forget the last steps, which is to share. Okay, you build already the analysis. You don't just analyze the data and interpret that. Okay, so you need to communicate your finding, your insight to others. So communication of your finding and insight to the relevant stakeholders or to public. Okay, present it in visualization to convey the key points. Okay, and then you publish this information for others to check, right? This should be repeatable. This is science, so that means everyone who has the same assumption, the same model, should be able to repeat and understand. Okay, so to create what is called informed decision. Okay, at the same time, once you have this, so you can build your own community to share ideas. Okay, so you can facilitate collaboration and informed decision making through this insight. Okay. I hope you can present your IFN stories, simple story, visual loops, narrative. Okay, and hopefully you can create videos and present it to others. Okay. Think about it. How can we share this model, okay, so that the people can see both the mathematics and the humanity in this model. Okay, so we hope that through sharing this insight and your model, of course, we can make the world better. Okay, we hope that there is a spirit of cooperation, fairness, and integrity. Okay, so remember, IFN itself is practically a mindset. It's not just the mathematics. Yeah? By looking at the loop, yeah? By labeling the nodes and the link, what is the meaning of link flow and so on. So you by ensuring the balance and recognizing the overlap that unify the system, then you can start to discover the pattern of fairness, yeah, reciprocity. Okay. So by connecting this to spirituality or morality and philosophy with the mathematics, then you can start to see something in the new light. This is what I hope. Okay, so yeah, think in terms of cycle. Yeah, think that what flow out must flow in. Yeah, when we give, we don't lose. We invest in the cycle that eventually come back to us. Okay. So the core principle of IFN is basically balance, reciprocity. Okay, and unity, interdependency, stewardship. Yeah, you treat the resources as a blessing to care and share responsibility. Of course, this is also about faith and hope, believing that by sharing this, okay, we can be in the interdependency in balance. Okay, so this is what I hope you can start to share with others through your analysis. Okay, so you can start to talk about environment sustainability, resource fairness, social good, and so on. So this is about system thinking and morality, okay, which is actually beyond the IFN itself, but you can go ahead and go aligning well with the ethical and our sustainable design. Okay, so think when you want to apply IFN, okay, you need to do it in the new way of system thinking. Okay, we need to think in terms of long term, not just short term. Yeah, we need to think in terms of cycle of karma, that our decision will eventually come back to us. Okay, so when we cannot make at least one cycle yet, so that means our thinking is not complete, okay, not finished. So then you start to combine, okay, these cycles, okay, to make the IFNs become the story of our life, okay, to build some community and stewardship. Okay, so this is what I hope that you can create the stories with the IFN, okay, in the long-term thinking that eventually will go to equilibrium. Okay, to apply IFN is basically to create story. Okay, so if it is an IFN, then it is good. Okay? If it is not IFN, then this is not yet good. Okay, so why it is good when this is an IFN? Because again, IFN is represent the ideal condition, right? So irreducible pragmatics. That means sustainable wholeness, equilibrium, balance, fair, and justice. Okay, long-term thinking. Okay, so imagine if our story is not whole, that means it is only partial story, isn't it? So it's not full story. So imagine if it is imbalance or unfair, that means this is only a short term, not long-term thinking. So in the long term, everything will go to equilibrium. Okay, and through the study of IFN, okay, so I'm learning that justice and fairness is actually pragmatic. Okay, fair is not always uniform distribution. Fair means give and takes. Okay, fair does not mean equity. Okay, does not mean equity, yeah? Not equality. So when the note and the value is not in the same, okay, then we can get fairness. Yeah. I give you some example later. Okay. Yes. Yes. Resource fairness. Yeah. Rafi said resource fairness is a problem. Correct. So knowing IFN make this a shared idea for you, okay, based on your own knowledge. Then you start to show through the mathematics. Yeah, we can get this adopting and cyclical thinking. Consequence of the decision eventually will return to every one of us. Okay, when you complete the cycle, okay, this is a thorough thinking, isn't it? So if your tracing is not yet a cycle, that means your thinking is not yet finished. Okay, so start to think, start to refining your thought until you can find the cycle. Okay, so trace the consequences of our decision until eventually come back to us. That's how you create the system thinking in a cycle. Okay, and in principle, once your network is set and you know how to the action node ripples through the cycle, then return and cause the consequences in terms of karma, then you can start to see that my decision is actually complete in a cycle. Okay, then you can start to think in terms of long-term thinking, then you can start to empathy to others, right? Recognizing how others can affect you and you can affect the others. Start thinking in terms of accountability also. Okay, so this is the point of studying IFN. This is what I hope. So I give you one last example. Yeah. So this is the wealth distribution. So let's compare a very simple wealth distribution. Okay. I will make it very simple, but let's interpret this a little bit deeply. Yeah? We will have three wealth distribution systems. Yeah? One is called unrestricted. This is based on capacity matrix. Okay. The second one is restricted. Yeah? This is based on the model mathematically. It's called doubly stochastic matrix. Okay. And the last one is balance. Okay. Let's compare the three. Okay. And to understand this, imagine this way. Okay. Each row or each column is actually a group or a company or a country. Okay, the way you think is each row, each column is a group or a country. Okay? And then each link in the cell represent the wealth of individual person or a company. Okay, so it is a smaller than the actual group. Okay, and of course the whole matrix represents the system. Is that okay? Can you imagine that? So yeah, this is the simple matrix. Okay, so this is capacity matrix. I have very simple number, which is 1 to 9. Okay, so how can we interpret this? Okay, let's say this natural number. Okay, its row represent the group. Yeah, its cell here represent the individual. Okay, or its row represent the country, and this represent the company. Say, okay. What happened? Okay, if you look at the numbers here, okay, the third row is the wealthiest in the system. So this is the wealthiest country or the wealthiest group. Yeah? The first row is the poorest, yeah, among this all. Yeah? And then if you check the value, so imagine this is the wealth distribution. That means this is the poorest, right? This cell top left is the poorest, and the richest is 9. So that means the gap between the poor and the rich is, in this example, 9 times. Okay, 9 times. So you can put this capacity matrix. Okay. Do you get the idea of capacity matrix here? Okay. There is a big gap between the rich and the poor. So 1 to 9. Okay. So again, you can set any value to individual cell here. Okay, but in this example, 1 to 9 is the gap. Okay, so let's do this. Okay, we can transform. So using your IFN Excel add-ins, you can calculate the doubly stochastic matrix. Okay? So 1 to 9. Okay, what will happen if we use doubly stochastic matrix? Okay, so doubly stochastic means the sum of rows is the same as the sum of columns. Okay, that means the total must be 1 here and 1 at the bottoms. Okay, so we can check the percentage. Okay, of course, this percentage you can multiply by the same total. Yeah, the total system in the total wealth in the system is 45, so you can multiply by 45 if you want to get the closer number to this one. Okay, but let's look at the percentage. Yeah, this is 9 times, right? But if you use doubly stochastic, now the richest in the column, okay, this is 39. Okay, and in the row is now 41. Okay, so now if you compare, the poorest still poor, this is 24%, but if you compare to 41, it's just double. Yeah, not 9 times, it's just double. So if you use doubly stochastic system, Okay, it will dump the wealth distribution. So this is very restricted wealth distribution, where each group must have the same wealth. That means we have equal grouping. Yeah? So remember, it's row represent a group or a country. So imagine if all countries have equal wealth, or within small countries, we have only three, in the world, only three countries. So within these small countries, we have only three groups. Okay, and the poor still poor. The richest a while ago it is 9. Now it's not really 9. Now become 28. Okay, so and in fact the local richest, which is 3 here, now become 41%. That means now the local richest is now become the highest in this whole system. Okay. This is what happens if you do communism. Okay. Equality for all groups. Okay. And let's do what will happen if we do IFN. So this is the capacity matrix is representing the capitalism system. Okay, no restriction on the wealth distribution, and double stochastic means you are very restricted in the system. Okay, now what will happen if we balance this? How to balance? That's the question, right? So that means in each group, the sum of input, the resources of input must be balanced with the sum of production, the output, within certain time frame, your own time frame. So within 1 year, within 5 years, within 10 years. So this the group, each group must balance the sum of input the same as the sum of outputs. What will happen if we use this rule? Pretty magic rule. Then the rich will still rich. So from 1 to 9 a while ago, now become 1 to 7. No, actually 4 times now. So it reduce the gap between the rich and the poor compared to the unrestricted. Okay, but at the same time, okay, it's also balanced. So I don't know. You have any question about this? Do you understand the points? When you interpret the matrix, the capacity matrix, in terms of wealth distribution system, then this is what will happen. Okay? Then you can set a rule. Okay? How will the wealth or the resources in the world can be distributed? Okay, so and this is what I propose. Now so we have 3 systems. One is unrestricted. So then when your system is unrestricted, that means the rich will become richer, the poor will become poorer. This is what happened in the field of properties. For example, in the Philippines, the property price will go up. How much? About 10% per annum, isn't it? But your salary will increase only 5% per annum. This means the wealth is unrestricted. So eventually it will go up, and eventually you cannot cut. It's a simplified way of communism. So the second part, the doubly stochastic matrix, is a simplified way of understanding communism. They restrict certain groups, right? So in that case, what will happen? Yes, it reduced the gap. Okay, it reduced the gap between the poor and the rich, but at the same time, okay, it will create new power within the local eventually. right? So, and because of that, okay, the gap is really very strongly dumped. Okay. So, because the well is strongly dumped, there is a problematic there. What is the problem there? People are not encouraged to work, basically, right? So when you rule everything, people are not encouraged to work because whatever they work, they will not get any value in terms of their production. So in that case, this is a problem of the actual communism system, the pure communism, as proposed by Karl Marx. Okay, so China adopting this, yeah, and then they changed into practically shifted into capitalism in terms of economy, not pure communism anymore. Okay. Now, what I suggest is actually we need to balance this. No? We need to balance in terms of we need to reduce the gap between the rich and the poor, but at the same time, okay, there is still productivity acknowledgement. Okay, so that means the structure still the same. So this is the way I think in terms of IFN. Okay, so then I ask what will happen if we do IFN from doubly stochastic system, say from communism, come back to the more balanced system. Yeah, so then the effect, okay, it will readjust the wealth distribution, okay, to be slightly better than doubly stochastic. But because it originally doubly stochastic, then the restriction still there. So you can start to see that the value is more restricted. Okay. So the original base value of the wealth distribution also matters in this case. Yeah. So you can check on your own. This is in Excel, so you can also compute on your own if you want, and start to interpret. Okay. Okay. So with this, I hope you can also share what you have done in your power dynamic assignment. Is it okay? Some of you, maybe not all, but yeah. Go ahead. Yeah. Yes, roughly man. Yeah. I think you make a very good cases on for the military application. Oh,
Yes, sir. Can I share my screen?
oh, sure. No,
Yes, sir. For a while.
yes. Yeah. Okay, I will put you as co-host so that you can share. Okay. Okay. Can everyone see his network?
Yes, sir. We can see his
Okay.
screen.
Okay. So explain, Rafi, and then let's discuss about this. Is interesting. Go.
Yes, sir. This one, sir, as my observation during my battalion days. So this is the flow of our operation wherein the battalion commander gives direct mission planning to the executive officer, and then from there on, it is the executive officer who plan out the support plan and the combat operation plan. And with these two staff for logistic and personnel who will support the grand plan of the staff for operation, that will be later be implemented by the company commander. And from that company commander, he cannot go directly to battalion commander for a feedback, for a debriefing, or any accomplishment. He will go through to his staff for operation, and the staff for operation will relay to the executive officer the mission report, or the report of that accomplishment. And from that executive officer, he will then relay to the staff to his staff, for personnel and logistics, the 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 plan that was accomplished by the company commander. And this staff, together with executive officer, will debrief the battalion commander. So from this flow of our combat organization flow, it happens that during the capacity, it is the XO have the more what's it called, that tasking. Yep. And during that premiere, I think it is the XO and the staff for officer who had the relative more important than others. But on the real McCoy, it is the battalion commander who has the command responsibility, has more authority. But it came through that during the premiere, it is the XO and the staff for operation has that more important. And using this cardinal rule, it is the battalion commander, and together with the staff, has the lower important on the organization. It is the special the staff for operation has more important compared to XO, to the battalion commander, though the staff for operation has more tasking in planning, in arranging, and monitoring, supervising that combat operation. As I observed this one, sir, I have some revision, refinement on our organization. I included the feedback mechanism from the commander directly to the battalion commander, who will debrief directly on what happened on the confrontation on the ground. And the staff for personnel and staff for logistic, they will not directly support the staff for operation, but rather they will directly support the company commanders on the ground. They will produce the personnel and they will produce the logistics. Within the executive officer, as you can see at my previous, wait, let's look. The executive officer who has the direct link for the staff for operation. Right now, on my propose is that the battalion commander, who was the direct, or has the authority for the plan, he will direct the executive officer to plan out what support should be given to the company commanders. And the battalion commander, who has direct operational plan for the staff for operation. So these two, the battalion commander, will be direct the staff for operation for the combat operation, while the executive officer will direct these two staff to support what plan of the staff for operation will do. So from this point, so I have some revision on the organization and add up a brief debrief arrow from company commanders to battalion commander, and eliminating the executive officer, direct staff officer. So I have this one on the capacity. the battalion commander and the XO has the more important role. But during and according to my cardinal rule, it is the company commander who was the more important. Though in real McCoy, company commander is the backbone of the combat operation. What will be the outcome of that combat operation will rely heavily on the on what action of the company commander from the plan of that staff for operation with the approval of the battalion commander. From this point, sir, this is just a brief organizational flow during that combat operation of our organization. That's all, sir. And a comment, sir, for the participants.
Super, yeah. So you are able to think of control, basically, right? You change this network in order to control so that the power will be on the officer that you that is needed. Okay. Excellent. Yeah.
Yes, sir. Thanks,
Yes.
sir. I'll just stop my share, sir.
Yes.
Sure.
So please continue this with the cycle analysis, okay, and then a pivot analysis if you want, so that you can get a better insight from this two IFN that you already created.
Yes, sir. Thank you, sir.
Super. Go. Who else want to share? Anyone? Lakson, Carlo, Lakonsil. Okay. Carlo.
Okay, sir. Hello, everyone. In this example, I tried to recreate the scenarios with inside the faculty room. What I tried to observe here is the communication flows of the dean up to down to the faculty members.
Can you share the screen, Carlo?
Sir, wait. Sir, I'm sharing already.
Did you see? Okay, good, super.
From this example, basically, the faculty cannot report directly to the cluster head. No, the players were dean, assistant dean, and the cluster heads, as well as the laboratory and lecturer. And below him, or basically the regular faculty member. In this example, the faculty cannot report directly to the cluster heads. And and the faculty must just, or basically he can only report to the assistant dean. The cluster head can give tasks to the faculty members, but they won't receive any reports here. No? So basically the assistant dean becomes the critical bottleneck in this type of organization or flow. And I tried to recreate this one. Basically, based on my cardinal flows, it explains that the powerful here is the assistant dean. Critical intermediary information controller, thus making it the powerful authority here. And the dean itself, even though he's the one with the ultimate authority, it kind of explains that he only has limited power. And basically the cluster heads were tasking the limited feedback only in this type of flows. However, when I tried to recreate the scenario when the cluster heads were basically they are collaborating with one another and the faculty will be able to report the whatever accomplishment they have to the cluster heads. The cluster heads as well as the faculty members, they have the same already power, and basically on the communication flows, the dean becomes the direct oversight over the strategic oversight over these scenarios, thus making well, basically a bit of not a, what do you call it, dictator, the assistant dean, then making or information making it more transparent to all the heads, and the certain powers were actually distributed below him. I think one of the key features that I've tried to observe here is that the bottlenecks for on the communication were tried to more open, and the information sharing were more fluid in this type of exam.
This
That's
is
all, sir. Thank you.
this is very interesting. Yeah? So you improve the communication, it will reduce the power of someone else.
Yeah, sir.
This is super. Is this really happening in your situation or just hypothetical?
Sort of, sir. Sort of. So I think the cluster heads were just, in a way, it seems like as if they're just there for the title or more workloads. Somehow, that's what I've also tried to or observe here in my modeling. And somehow, kind of, in reality, it's still kind of happening.
So probably you can propose that, yeah, to improve of communications and
Well, I'll try to talk to the assistant din that basically I'll give the idea that he really is the powerful guy in our
more powerful
organization.
than the team. Yeah.
Yeah.
Yes.
Powerful.
It showed
That's
actually the
also
structure really matters, right? So the structure really
in
show
the community.
the power.
Yes, sir.
Yeah, super. Thank you for sharing this. So anyone else want to share their work? Yes, Ray. Yeah. Go ahead.
Hi, sir. Hi, classmates. Good evening. Can you hear me?
Yes, yes.
Okay, so I'll be sharing my screen. Are you able to see my screen?
Yeah, okay, cool.
Okay, so in my model, in this assignment, I chose to model the existing whale shark interaction systems in the Philippines. So the local name for whale shark is butanding. So if you guys are not aware of what they look like, these are what whale sharks look like, or butandings. So these are basically the largest living fish on our planet, and the Philippines lies on their migratory patterns. So they swim on our oceans, but most notably on Donsol, Sorsogon, and Oslob, Cebu. So whale shark interactions are tourism-oriented activities that enable foreign and domestic snorkelers and divers to swim with the world's largest fish. And you can do this in Donsol, Sorsogon, and Oslo, Cebu. There are also other locations, but these two towns offer the most um, already established systems in place. So the system in Donsol has been viewed or lauded as generally ethical and responsible. There are systems and local policies in place to ensure that the well-being of whale sharks are still protected amidst tourism-related activities. Meanwhile, the practice in Oslo has been criticized due to lax government intervention on this activity, leading to more aggressive tourism behavior and boat operators feeding the whale sharks. So in Oslo, the tour boat operators actually feed the whales, the sharks, I mean. So the sharks tend to linger longer on those tourism heavy areas, which also makes them attracted towards fishing boats. So it tends to harm them, and the motor of the fishing boats can wound them. So it already starts affecting their dietary habits and migratory patterns, because naturally whale sharks are migratory. So they don't stay in one place for a long time. It's just a part of their natural migratory patterns. They swim all over the world, eating plankton on the warm tropical waters of the planet. So these two systems have been compared in several articles and blog posts. If you follow National Geographic, um, and if you're fond of doing these kinds of activities, you will be probably aware that they are being compared, these two systems from each other, because one is viewed as ethical and one is viewed as not very ethical due to the local practices. So that became the brief for the modeling of using IFN. So I used the Donsol Sorsogon system as a base model, and then I compared it with two more models. The first one is the off-season model, but same location in Donsol. And the third one is the Oslo Cebu model. So all models include 5 nodes. The first one is the tourists. So these 5 nodes represent different motivations of what they can achieve or what they can gain from interacting within the system. So the first node is the tourists. So these are visitors and divers who visit the locality to swim with whale sharks. The second node is the whale shark interaction officers, or BIOs, the Butanding interaction officers. These are specially trained guides that swim and direct tourists along the swimming path of the whale sharks, ensuring that they maintain a safe distance. So these are basically tour guides that help the tourists to stay in a safe zone, not touch the whale sharks. So they do that, and they are licensed or certified by by the local government, as well as the different wildlife organizations, ensuring that they preserve or ensure the safety of the whale sharks, of the animals. The third one is the local community stakeholders. So both Donsol and Oslo have a similar small town municipality character. So there's a lot of fisher folk in both of these towns. And once the whale sharks were discovered, the local fishermen were also one of the beneficiaries of this tourism boom, because instead of having fishing as their livelihood, they converted their fishing boats into tour boats instead. So tourism became one of the more contributed more to the local economy by helping the fisher folk have a different source of livelihood. So These tour boats are the main mode of transportation for both the BIOs and the tourists in order to conduct this tourism activity. And then the fourth node is the local government and tourism office. So it represents the municipal government and all attached agencies with the interest of sustaining this practice as a source of tourism and as a source of revenues. And then finally, we have the last node, which is the whale sharks themselves or the species. So it's really important to include them because they are the most essential part of the system.
Right.
So yes, now we move on to the actual modeling for the IFN. So the Donsol Sorsogon model, I assigned essentiality points for each interaction from 1 to 5, with the 5 being the heaviest. And we learned that the most powerful node or most powerful player in the Donsol Sorsogon system is the tourists or the visitors and divers. And the least powerful is the local government and tourism office or the LGU, World Wildlife Fund, and different organizations. And it's a bit similar with the off-season model, but for the off-season model, I deducted -2 on all interactions from the Donsol Sorsogon model because from June to November, whale sharks tend to be rare. Sightings of whale sharks tend to be rare in Donsol Sorsogon because they're somewhere else since they are migratory. So their presence overall is deducted. So I deducted 3 on all interactions. And since there is less sightings of whale sharks, there will also be less influx of tourists. So there, I deducted -2 on the tourism influx. So for this model, for the off-season model, the tour boat operators emerge as the most powerful, and the local government remained as the least powerful. So right now, we may be thinking parang where do the whale sharks fit in all of this? So in both Donsol, in both models of Donsol, the regular season and the off season, they rank as the second least powerful. They ranked as fourth. So that was consistent on both models. So now we compare with the last model, which is the Oslo Cebu model. So in Oslo, where there is generally less government intervention than Donsol, so that means less government oversight, less stringent policies, as well as less equipped BIOs. So that will lead to more volume of tour boats as well as more aggressive tourists since policies are more lax or are less stringent. So, but still, we made the presence of the whale sharks consistent since it is part of their natural migratory route. So here, the whale sharks actually emerge as the most powerful player in the system, and the whale shark interaction officers or the BIOs emerge as the least powerful. So on any normal network, especially a human network, we would expect that the most powerful player in an IFN would be the ones which gain the most from the network, or the ones with the most power, the ones with the most benefits accrued to them. But what's interesting in having a human and nature model is that when nature is involved, since nature doesn't have agency, nature only reacts to external and internal stimuli, and humans have agency. When they emerge as the most powerful in a model, I think we can infer that they also have the most to lose. So I concluded from this analysis that, yeah, in the context of human and natural interactions, increased involvement or exposure of a species of wildlife to human activities can lead to more detrimental effects to their well-being. Therefore, the fact that whale sharks turn out as the most powerful players on the OSLOP system may actually be harmful to them. They serve as a primary tourism and economic draw for the local community, which encourages more dependence and unsustainable practices. Meanwhile, in both Donsol models, the whale sharks remain at rank 4, or the second least powerful, which may mean that they are less attached to the network, or there are enough healthy systems in place to minimize human interference on their behavior. Since wildlife creatures such as whale sharks don't have agency, as what I have been mentioning earlier, their mere presence become the spectacle and draws tourism. So they don't go to these places to since they don't have agency, they don't go to these places to draw tourism. They just go there because they're feeding or it's part of their migratory route. But it was the humans' activities who decided to make the most out of this natural phenomenon and make money and generate tourism. So when they leave, the tourism is gone as well. Now, this is healthy and sustainable because they will eventually come back, and there will be eventually more opportunities for tourism in the future. But when they start gaining agency, when the whale sharks start choosing to stay in one location because of the abundance of food, because they are being fed by the tour boat operators, by the fishermen, because they want them to stay longer, because they want to generate more tourism money, they gain more power in the system as they become bigger tourism draws. This is harmful to them, and this is the case with Oslo. So those are my findings. And I had really fun. I had a lot of fun with modeling this.
Yeah. It is wonderful that you include the whale, okay, as one of the agent here, right? This is the most affected agent that then you include that, yeah. So this is super, yeah, wonderful. You're supposed to make a paper or continue this study. I think this, if you inform this result to the world, I think this is really wonderful. Very nice.
Sure.
Okay. Kenneth, yes, you want to say something?
Yes, sir. I would like to present next.
Okay. Is there any comment before Kenneth? Is there any comment to Ray?
Very informative and eye-opener, Doc Kardi.
Yes. Super. Okay, Kenneth, please.
Can you see my screen, sir? So for my assignment, I prepared a model of our organization in our office. So basically, it's all about the project implementation process flow. So once we have the list of projects for the current year, we started the planning and implementation of these projects. So it started all with this from the Office of the District Engineer. So this office directs the preparation of the engineering drawings and plans, as well as the program of works to the planning and design section. Then once all these plans were made, so it will be then proceed to the procurement of these projects. So that's why there is a link between the planning and design going to the procurement unit. So once that the procurement activities have been made, so these contracts were then awarded for implementation. That's why there is a link between the procurement unit going to the construction section. So since the construction section is the unit basically supervising all the implementation of these projects. So they played a crucial part in the project implementation process. So after this, once that they already completed or have some accomplishments, they would request for the financial obligations and disbursement from the finance section. So this cycle makes it fully complete. And as you can see, the backward link basically going to the Office of the District Engineer, mostly on reporting of accomplishments. So this will be our base scenario. And for this scenario, it can be observed that the Office of the District Engineer, as well as the construction section, plays the most important role or influence in the project implementation process. So it can also be observed based on the computed relative power that the planning and design section, since they are the ones who are preparing the first crucial step in preparation of the plans and programs, as well as the finance section for the processing of disbursements, as well as the obligations of cash and other budgets. So they are deemed the second most important unit for this process. So as a modification, not really modification, in order for us to identify and optimize the process flow, I also introduced some links. So like this one from the construction section. So in order for us to continually monitor and evaluate the completed projects and to identify future proposals or projects, so based on the prepared as-take and as-built plans, they will provide these inputs to the planning and design section, which will be used as reference in the preparation of future planning. And in order to fully supervise all the processes included in the project implementation activity, the Office of the District Engineer also has to monitor and direct other units like the procurement unit and the finance section, particularly in monitoring the procurement activities about its status, as well as the status of the disbursement and obligations of all the funds being downloaded to our office. So based on this modified scenario, it can be observed that in the computation of the relative power, the Office of the District Engineer has the most powerful or influence based on authority, since they are the main head office. So also, since the construction section is the main player for the project implementation, it is identified that they are the second most important role. They play the second most important role in the organization. And as you can see, the planning and design section and the finance section still plays a crucial part in the implementation of these projects. Okay, so by adding additional interactions and feedback mechanisms between different components of the organization, the process of project implementation has been optimized. So there is a better link in supervision about the project implementation.
So,
So that's also very simple.
oh, this is very nice. Okay. Can you put the row is divided by the minimum rather than the maximum? Is it possible?
Sir,
Yeah, this row, the
this
W,
one?
yes, divided by the minimum rather than the maximum. Is it possible? So that we can see that this is actually 6 times and the other one is like 2 times.
This one, sir?
Yes. So become divided by PU, the 2, right? Yes. So, and then now you put the dollar sign first before.
I think so.
Okay. This one is like 6 times, huh? The power is like 6 times. Now go
Yes, sir.
to the second scenario.
For the
Yes,
new scenario, sir.
right. The same thing. So that one divided by the minimum, which is again 0.14. Okay. See, this is only 2 times. So it's the power is more distributed now compared
Yes,
to
sir.
the first one. This is like in the first scenario, it is very powerful. These 2 officers are very, very powerful.
Yes, sir.
6 times. Wow. So by putting this communication links, very simple, right? Just adding communication links, so you can actually make it more
Optimize, sir, and distribute the influence, sir.
correct. So yeah, so this is very nice way to control and to predict what will happen. So I hope you can share this and try to check whether when this is implemented, this is actually true or not.
Yes, sir. Actually, the Office of the District Engineer regularly conducted monitoring and supervisory activities, sir, so that all our processes will be in place.
All right. Yeah.
That's all, sir.
Thank you, Kenneth, for sharing this. Yes.
Sir,
Yes.
I have some clarifications to Kenneth, and then I want to go next because mine
yeah.
is very close to him.
All right.
So this is a bureaucratic process, similar to what the military was
Yeah.
presented earlier. Just to confirm, Kenneth, is your scenario 1 the observed scenario, the actual operation district?
Actually, not necessarily.
Because the second scenario should be by policy
The base
actual
scenario.
Yeah.
Yes, yes. So I just presented it as the base scenario so that we can observe the influence or the effect of adding additional link or connections between other offices.
Okay.
Yeah.
Thank you, Kenneth.
I know you will ask questions about it.
Yeah. We're of the same agency, by the way.
Yes, that's right.
Okay. Mine is
Thank you.
thank you, Kenneth, again. Mine is more of an inside look to the planning and design section as presented by Kenneth. Let me just... Is my screen now sharing?
Yes.
Okay, more nodes. Because we're looking on the personnel level. and how they interact with their boss on a hierarchical organizational structure. So in this kind of structure, we expect that the section chief should have the
Yes.
most power. But the interesting results later, in terms of the strength of influence and the relative power, he may not be. Okay. On this one, figure 1 is the typical organizational chart of a planning design section, where you have planning engineers and some technical staff under a planning wing or unit, and then surveyors, designers, cost estimators, and draftsmen reporting under designers under the design unit. So the design unit is more prominent in terms of, or more intricate in terms of organizational structure, because most of the activities fall under this unit. Then you have third one, which is more of a support unit, safeguards unit, wherein envi and resettlement actions were specialized. So you have a specialist for both areas. And then an administrative unit who acts as a secretariat to the section chief. So if we model that, you'll have figure 2. So the admin has no direct influence to the unit heads, but the unit heads can direct the admin. So going to A0. But the admin can directly influence his or her boss or the section chief. And then mostly two-way communications between the bosses and lateral communications within units. No lateral or diagonal communications in between units. This is usual observed model. So as an assumption, in terms of the capacity matrix, the relative capacity or strength assigned to the section chief is the highest, which is 4 times than the normal staff, and then 2 times than the usual personnel would be the relative power of the section heads or unit heads. So that's 2 for the planning, the design, and the safeguards unit. Okay. This is reducible based on the structure, but this is not pre-magic, this capacity matrix. Okay. As to the premier network, so the weakest would be D4, and based on the assignments here, D4 is draftsman. And as noted, he's the bottom of the hierarchy because he's under the personnel whose level is 2nd or 3rd ranking. So the results of relative power in terms of the premier network is somehow expected. However,
what is that? T0.
The design unit head has equal power to his or her direct supervisor because of probably because of the intricacies of the said unit. It's more prominent. And then in the cardinal network, the relative scales of power are more than doubled.
16 times.
Yes, the section chief is 16 times more powerful than the quote-unquote bottom feeder here, the draftsman. And then the other section personnel of the design unit are 2 to 4 times as powerful than the draftsman. So in Tagalog, they are the most kawawa in this scenario.
So is this happening? Is this really happening or?
Yes, sir. We call them runners for those draftsmen that were not given the actual assignment of drafting.
Okay.
Okay. To improve this power balance of power, so I introduce links that may improve lateral and diagonal communications. Number 1, between units or personnel of same levels, the 3rd ranking personnel to 2nd ranking personnel. And then the the admin has now direct, or the secretariat has now direct influence over the draftsman, and then also to the technical staff of the planning unit. So it's somehow an indirect link to the section chief already if you're connected to the admin. So you can give grievances, for example. So now, again, assigning the capacity matrix in terms of 4, 2, and 1 on the same structure. Again, the capacity matrix is not yet pre-magic. To the relative scales, it definitely improved from a multiple of 7 and 5. Now it becomes just 2.5. But here, on the Premier network, the design unit head is now the most powerful. 3.5 times than the draftsman and the D3, which is the cost estimators. But looking on the cardinal network, this is more balanced except for the NVI specialist. Now the NVI specialist is the weakest on the cardinal network. Same goes. This can be explained because we didn't put feedback loops for the F naught or the F unit, which is safeguards unit. There is no direct feedback loop into the secretariat going to the section chief or a lateral functions in between, except with the surveyors and resettlement specialists. So that's why the NVI now is left hanging based on this structure. Now, just a point of interest here, I tried doing converting the capacity matrix of the second scenario into the pre-magic capacity matrix. In the true here. Now the capacity matrix is pre-magic. So to make it pre-magic, the most powerful link should be from the draftsman feeding into D2, which is their design engineers or their direct supervisors. So this should be the strongest link. And then converting that to the integral network, because the cardinal network, we have too large of an LCM. Imagine multiplying 717, 715, so on. So I decided to use the integral network instead. And then you have a more balanced power. And now, instead of the design unit head, it's now the design engineers who dictates the power by 4.5 times the environmental specialist.
Yeah, this is super interesting.
Yeah, and on this one, if you use the pre-magic capacity matrix, the power is devolved to the staff.
Oh. Yeah.
So I don't think it's ideal. The most ideal, I think, is still scenario 2, but we need to introduce more links to the NVI staff so that he's not the balance of power would shift into lesser ratios instead of
probably your section chief does not want this also, because of course he wants to be the most powerful.
yes.
So then you can start to find a scenario, okay, changing this network structure that eventually will give balance, but at the same time give him more power or her.
Yes, sir.
So that's the part of the control that you can start to simulate.
Yeah, I just find it interesting that in order to do that, the so-called bottom feeder should be given most power in
Yes.
terms of the influence.
So actually, this is very interesting. You all go beyond my expectation already. Okay. But at the same time, did you find this interesting enough, right? That through a simple, diagrams, now you can start to see their power. and now you can even see this in your own life, basically.
Yeah, the same example as the family structure and class.
Yes. Yeah. So thank you for sharing all of this. Yeah. Is there anyone want to share further or any question to Rins?
Could that be part of assessing the salary of every individual? Who has the most power should have the most salary. Okay.
So
There
if
are
it is
many
the
comments.
draftsman who have the more power, then the higher salary will go to the draftsman.
I think that should be done with our elective officials.
So you can start to analyze whatever it is system that you can think of. Okay, whether it is politics within your own family, within your office, right? Or within your organization, it is in the church and so on. So you can always analyze by doing very simple, right? Actually, and it's fun. Okay. You also want to know, right? Yeah, super. Yeah, thank you. Archie, you want to say something?
None, sir. None, sir. None.
Thank you. Anyone else want to share? I think we still have a few minutes. Yeah, super. So, those who did not make it, please make it. Okay, I think this recording also can be used for you to get a reference. Okay, and those who share, thank you very much for your sharing, and continue and make it into real and really use it for the real world within your office, within your community. Okay, I hope this is useful. Okay, then. Anyone else want to share? Last chance. Okay, Rafi, you want to say something?
Sir, I'm just a clarification, sir. If for all those assignments, sir, assignment in IFN, let's call it this assignment, sir.
This assignment power dynamic.
Yes, sir. Could we have some assignments of our classmates, sir? We could probably use that in our organization, like for example, SURP.
The recording will be there, right? If you want to get their assignment, so
Yes, sir.
you ask for their permission.
Yes, sir. Thank you, sir.
Who is there anyone want to share? So please share it to Omar Sharif. Can you organize the sharing if they want? Omar is not there.
Sir, yeah, I'm on mute.
Okay. So can you organize?
Organize sharing, sir.
Yeah. If they want to share, so let them share. Okay, and then people can start to learn from each other. I think this is also very nice.
Okay, sir. So maybe do you mean, sir, one repository or a
Yeah,
session?
you can put it in one repository. But
Okay, sir.
actually, I encourage you to make it public, rather than just private. Yes.
Okay, sir.
Super. Yeah. Thank you.
Do we have that in Rev, sir?
Oh, you can create some repository, and then those who want to share, let them share in that.
Okay, sir.
It's just need to share to each other, isn't it?
Yes, sir. Do we have that function in Revolido, sir?
Or
Or
what?
do we have that function for
Sharing? No.
compiling? No. Okay. So maybe I'll just share
I think
share drive.
you can share it in GitHub or in GitLab or whatever. Public.
Yes.
Uh,
Okay,
if you
sir.
don't like it to make it share in public, you can make it private. That means
Yes.
only those who join can have those files.
Okay.
Yes. Thank you. But I really encourage you to publish this, you know, not just for among us, but really for public. Okay. If you are confident enough, go ahead. Okay. And this is very nice, really. Okay, so with this, let's go to the next topic. Is that okay? You want so I got some feedback from the previous semester. They said 3 hours is too long. Can we have a few minute breaks? So okay, let's have a break, maybe 5 minutes. Okay.
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 Thank you, Dr. Kardi.
Okay, so let's meet again at what time? Now is what time is it now?
7:54.
Oh, okay. So let's go back at 8.
Okay, Doc.
Okay. I will open. Yeah.
Yes, sir.
Right. Okay, let's come back. So, one thing that probably I can give you feedback from your a few presentation a while ago is the same like what Ray was presenting. Yeah? So can you also add note on who is the most affected? For example, probably the product or the clients. Yeah? So in the country is the citizens. In the company, probably the customers. So if you can get the most affected people or agents or products inside as note, that probably something interesting. You can start to see what will happen. Number one. Number two, can you also do cycle analysis? Yeah, the same network that you have is practically just adding what is the cycles, and then what are the cycles, and what are the pivot between cycles. Okay. It's already there, so just add those two, and then start to interpret what is the meaning of this pivot. Then you can start to see, oh, these are actually the most important part in the communication network. Okay. Oh, this is the one that are crucial that we need to take care in your system. That is if you can analyze further using pivot analysis and cycle analysis, then you start to see, okay, which one is the most important in this system, okay, of communication. Then you can start to see, okay, in this case, I need to take care of this part. Okay. That is talking about prioritization. So our next topic, okay, I will start very simple again about prioritization. Okay, and then later we can build up more complex. Okay, you go to Moodle, right? So if you go to Moodle, so we have finished our first topic. It is ideal flow network, right? And now we are going to the second topic. Yeah, so prioritization. Okay, and later after that, this is continuation. Yeah, decision theory and game theory. These are all continuation of this. Okay, so let's start with the first one. Yeah, prioritization. And then I hope we can finish. And this one have a lab if you want. Open this NCDM calculator. If you go to MCDM calculator, this is a real calculator that you can use. So MCDM means a multi-criteria decision making. Yeah. So this is a tool to prioritize, okay, of alternative based on multi-criteria. So how to use is just 1, 2, 3. So step 1, you create the alternative and the criteria. So you set how many alternative, how many criteria. Okay. So alternative, of course, for example, the alternative are the projects that you want to do or the tasks that you want to do. Criteria are the factors, right? So you click next, then you can rename this one. Yeah. So what are the criteria? And you can put any weight values. Okay, and then when you click next, you can get random value here. Okay, so when you calculate, then you can get the computation. Anyway, if you want to do it Excel, you just fill it up exactly the same, and then this is just some product, and then you run. Super simple. Right. Okay, so let's go to the actual slide. So I go to the slide of prioritization. Can you see the slide?
Yes, sir.
Okay. So how do you prioritize? Okay, so let's talk about the simplest prioritization. Okay, so usually you will use important and urgency for your daily life, and then we go to optimization. Okay, so this is our course is about optimization, and then let's discuss about transform project. Yeah. Okay. So why do we need to prioritize? Yeah. So of course you want to make informed decision, right? About how you allocate your limited resources. So you need to prioritize because you have limited resources. Yeah? You have limited time, you have limited budget, you have limited number of people. Okay. And you want to align that resource with the long-term goal that you have, yeah, the objective. Okay. And then of course you want to have we want to identify the area where your improvement will have the greatest impact. You want to optimize this. And at the same time, you want to manage the risk, right? So, and you want to create probably some kind of accountability, transparency for your decision making. So that's why the prioritization is needed, right? So what I mean by the last part is, say if you don't show how do you prioritize based on arbitrary, then in your project, yeah. So then there is no real accountability. What is the basis of your prioritization? Right? So people can question this. Why you put so much million or billion of pesos for a certain project, not the other project? Right? So in that case, we need to create accountability and transparency that I do this because I optimize. And these are the constraints that I have, these are the resources that I have. With that, you can start to see, okay, I prioritize with reasonable and logic and accountability. Okay. So let's start with the personal level. Okay. So you have, when you prioritize, how do you prioritize? Okay, for personal level, I usually use this. Yeah, IU, yeah? Importance, urgency quadrant. Right, we have 4 quadrants, 2 by 2, yeah, 4 cells here. So when the task is important and urgent, then you put label A. Right, when the task is actually important but not urgent, you label it as B, right? And then when the task is actually urgent, not important, you label it as C, and then not urgent, not important, like, so probably pleasurable entertainment. So you do it as D. So of course you will say, I will do priority A first, then B, and if you have time, then you do C. Yeah, these are the normal way to do prioritization for the tasks that we have. But let's start to think in terms of internal and externalities. Okay. Who actually force you to say that this is urgent or not urgent? Okay. When you have a list of tasks that you need to do today, okay, who tell you, okay, this task is urgent and this task is not urgent? So is this within yourself or actually external pressure toward you? Okay, so if it is within yourself, then of course there's no problem. But when you put urgency based on external pressure toward you, then the value of this importance and urgency slightly change. Okay, later you will, if you do this based on external pressure, then you are responding to external pressure rather than actually inward out. Yeah, so the way you prioritize eventually become like responsive only. Okay. In that case, maybe you want to add more factors, not just urgency and important. So you probably want to include internal pressure or external pressure, whether it is actually satisfying me or not, okay, and so on. So all the factors that you can include, you can put them, and then now you will have multi-criteria prioritization. Okay, so you can practice. Okay, you can list down for personal planning. Okay, your own activities and tasks. For example, what you will wish to do next week or tomorrow. Okay, and then you can set the priority to be A, B, C, or D. Okay, and of course you have more than 4 tasks. Then A1, A2, A3, and 4, and then B1, B2, B3, and so on. Okay, so it will become numbers, and then can you estimate how long you will do its activities, and can you also estimate the value? Okay. How to determine the value is up to you. This is ordinal number. So say we can just agree that the worst is 0 and then the best is 100. Okay. It is very subjective. Yeah. So for each activity toward your own personal goal. Okay. So then can you set how long you will do some activities? Okay. Once you have done that, can you sort? Okay. Which activity should be prioritized given the limitation of your time over the others tasks, right? Do you want to do this now or later? Okay, so you
The
can
MCA, sir?
huh?
The MCA lang.
This one, the personal planning.
Wait.
If you want to do it later, so I can put this as your assignment. And then I want you to optimize, of course, based on these two. Is it okay?
Yes, sir. That's much better.
Okay.
So we can decide.
Okay. So okay, this is what you need to do, and then you sort the activities. Okay, and then I want you to do optimization based on this, your own personal planning, okay, of the day or a week. Okay, it's not really matter. So using the IU, the important and urgency quadrant, of course, it's very simple, easy to use. Okay, but there is a assumption behind, right? So you assume equal weight in the importance and urgency, and there is no actually time component. Okay, and then the long term is supposed to be higher priority than short term, right? So if that is true, then the B must be higher than A. So the problem is we probably need more criteria, right? And we may put different weight, okay, on each criterion. So here are the list of a few lists of criteria or that you can use. Yeah? So these are the important and urgency. So you can read by yourself the meaning. Okay, and then you can also put the time. Okay, time based, right? So whether it is very short term, mid term, up to lifelong term. Okay. or you can add additional your own criteria. So these are the several example of criteria that you can use. Is it necessity? For example, is it essential to use this idea or this task? Okay. And how useful is this? Okay. And how much potential? For example, it's free to add your own criteria. Okay. Is it simple? Okay. Is it can I do it? Am I capable to do this within your company or within your own personal capability? Okay. Or is it interesting enough? Do I enjoy it? Okay. So everyone have their own criteria, subjective criteria. Okay. Is it curiosity? Is it something new? Do I really want to know about this? Or is it satisfied? Make me happy to do this or not? Right? So these are additional criteria that you can add. So normally for the project, of course, you need to add the cost and benefit, right? So that is the more quantitative criteria, that more objective than this criteria that you have. Satisfaction, interesting. These are ordinal numbers. Of course, this is very subjective. Okay. For the actual project, so you need to add cost and benefit. Okay, so cost mean how much money do you need to spend for this idea, okay, for this project. Okay. Of course, if this is very expensive, then you should put 0 probably. So again, you can put as actual cost or actually ordinal number. Okay. And then the same thing with the benefit. Okay, how much additional earning will you get from this idea? Okay, so is it monthly you will earn or one-time big? Okay, so this can be computed later. Yeah, during financial analysis we can discuss more detail on the cost and benefit analysis. Yeah, and again you can add many other criteria that you put, including confidence. Yeah? How much confidence level you have in doing this task and so on. Now I want to propose, okay, for you. Okay, this is not my own algorithm. This is already well known. Okay, so you're supposed to know this, and this is called knapsack problem. So you can search in Wikipedia or in Google knapsack. Yeah, this is the idea of knapsack for optimum prioritization. Yeah. So let's go to the informal discussion first. Yeah. So can you read this for a while? Are you done reading? How this philosophy professor actually suggests to prioritize? Yes, Sam.
Hello, sir. I think I get the professor's point in this narrative, but prioritizing family, health, and passions is important. But sir, I think life is not as simple as filling a jar in a perfect order. Sometimes work, responsibilities, and even small tasks demand our attention first, like answering emails or dealing with errands may feel like sand,
Okay.
like what he mentioned here. But they also keep life running smoothly. So that said, sir, the professor's message is a good reminder that not to get caught, not get too caught up in the little things and forget what truly matters. So I have had days where I stress over a minor task and realize that I miss out on time with my loved ones. So is this the best life strategy? I think so. It depends. Like priorities change, and I think balance is the key. So instead of strictly following this approach, we should learn when to shift our focus, when to hustle, and when to pause, and when to let go of the small stuff, and when to handle it before it piles up. And also, we need to learn when to drink a beer. Thank you, sir.
No. Okay, so the strategy suggested, yeah, this story of philosophy professor to fill up our time with the most valuable, okay, or the most important thing first. My question to you is the above strategy optimum in our life or not? Okay, so it seems like probably optimum, and you said a while ago is not really, yeah. So it depends on other factors as well. Okay, so I want to give you a counter example. Okay, that actually what called the wisdom from that philosophy professor story above is not really optimum. Okay, okay, the way it presented was very nice. Okay, but let's do numerical example. Okay, that the wisdom from the philosophy professor is not the optimal strategy. Okay, if the life is actually under constraint. Okay, let's do this with the task that I asked you to do a while ago. Okay, say you have how many? 5, 6, 7 activities, 7 tasks. Okay, and you have only 10 hours per day to do all your daily activities. Okay, so so you are considering many alternative activities. If you total all of this, the total of hours, yeah, so it's clearly above 10, right? Yeah, 3 plus 5 is already 8, right? Plus 2.5 is above 10. So you have only 10 hours. You are strict with it. So you have 7 tasks, and these are the estimated times in terms of hours. And then these are the values. Okay, you want to get the most value out of these activities. Okay, so the question is, what strategy should I do to prioritize these tasks? Okay, so let's play. Okay, let's do it. Number 1. I want this is the most this is the wisdom from the philosophy professor a while ago. Yeah, I want to do it the most important values. Okay, let's sort that. Okay, so do only the activities with the most important values. The technique is simple, right? So we sort the task based on the importance. Okay, the values here. And then we select the first few of the activities, right? Up to the time is up. So the time is 10, correct? So then if you sort this, so from 10, 9 until 4, the least one, okay? And then you will get this hours. The effort is 8. If you add 2.5, this is more than 10. So not okay. So you will do only A and B. Okay. So the total time is 8, and the total value is 19. Okay, 19. Yes. A reality question in all this, where I can put politic workplace. What do you mean by this one, Chin Mary? So let's do the second strategy. What will happen if we fill up, okay, our time with the most valuable first things, okay, and then we spend the rest, right? So this is exactly what the exact strategy of that philosophy professor, right? So we do exactly the same a while ago. We sort, okay, based on important values, and we have 3 plus 5 here is 8, and then to make it 10, so we search which one is to make it 10. So 2, Yeah. So we get the total time is 10 efficient, right? So total value increase, right? Instead of 19 now become 24, correct? Oh, increase. So second strategy is better. Is this optimum? We don't know. Okay. So let's do some people want to do something else. I like the most challenging first. Okay. Strategy 3. Okay. So most challenging means let's do the most time first. Yeah. So regardless the value. So let's do the most time. So 4.5 plus 5, that means 9.5. And then now you sum up the value, it is only 16, 9 plus 7. So in this case, because the limitation of the time is up to 10 hours, right? So this is already 9.5. So, and there is no other 0.5. So in that case, you only do activity B and D. Okay. So it is lower than strategy 2, isn't it? Oh, so strategy 2 is still winning. Okay. Some people like to do some other strategy with this. No, I don't like the most challenging first. I want the easiest first. Okay, that means the easiest means I want to do it the least time. Okay, and then you find the higher value. So in this case, what you will do, you sort the activities, okay, based on the effort, right, from the least up to the highest. Okay, and then you sort again the second sort based on the values. Okay, for example, this one 2.5 and 2.5. So of course, you will put 8. Yeah? Value 8 is higher than value 6. Okay, so you sort 2 times. Okay, so then the result is this one, because the total is 10 hours. You will not get 10. Yeah, you will get only 8 hours. Okay, there is no additional 2 here. So there, you get the total time 8 hours, the total value 23. Oh, quite good. Better than the most challenging, but still less than this 24. Right. So again, seems like the philosophy professor strategy is still the good one, yeah, the best one. So let's another way. Yeah? Strategy 5 in here, I do the most important values after eliminating the difficult effort. Okay, why? Because some people use their fear to decide the strategy in their life. Okay, so that means when you use fear, you use the combination of strategy, okay, by setting the threshold on the challenges. Okay, if the effort is too much, then a certain threshold, then you will not do that activity regardless the value. Okay, if the effort is actually smaller than certain threshold, then you will do the activities with the largest value. So what I'm trying to do here is I'm trying to, when you see the strategy, okay, try to put that into numbers or mathematics, yeah, so that you can start to see that we can actually compute. Okay, so okay, let's set the threshold of effort that you feel too much for the time being. So in our case, let's put the effort 2.5. Okay, and so then if more than 2.5, you regard this as too difficult. 2.5 hours. Okay, so in that case, you will delay, yeah, postpone. By setting this, you practically remove activity B and D from your list up above, and now the activities become like this only. Okay, and then by setting 2.5 hours as threshold, you remove activity B and D, which is higher. Okay, B and D is 4.5 and 5. Okay, so then you sort the activities based on the value of the most important, yeah, to the list. Okay, then you select this few. Okay, again, if you calculate, you will get total time 8, and the total value is 23, which is exactly the same as earlier. Yeah, this one also 23, right? So the easiest is 23. So strategy 5 is not even better than that philosophy professor telling a while ago. Okay, let's create another strategy. No, let's do it the fastest and the highest value. So strategy 6, okay, is selecting the fastest and the highest value. Okay, meaning the least time and the higher value is the aim. Question, is this really optimal strategy? Using this, what you will do, you will sort the activities based on effort from the least time consuming activities until the most activities, and then you sort based on value. Okay, from the most valuable until the least valuable. So sorting. The way to sort is matter in this case, right? After that, you select the first few activities of the highest value, until the time is up. So in this case, you will see, okay, after you sort, this one, this is the sorting less to higher, and then after that, you sort again based on the most valuable. And we get total of 27. Oh, this beat the philosophy professor, strategy. Remember, the philosophy professor a while ago was 24, right? So strategy 6 is actually the highest. Okay, so in this case, this is the strategy that we have. We compare. Okay. Now, my question to you is: this 6 strategies as the really optimum? Okay. Apparently, it is not. So the best strategy will have total time of 10 and the total value of 99, which is A, C, E, and F. Question is, how do we get that optimal strategy? Okay. So if you do manually, this is really hard. Okay. So, but fortunately, there is already a technique based on, based on, what is called knapsack problem. Okay. So knapsack problem is simple. Okay. You have a knapsack. So imagine a hiker will pack his knapsack for his mountain tour. He has n object to bring. Okay. Each object, say, call this object I. You have 1 to n, right? Each object have certain weight. Okay. And then it will give him certain benefit, certain value, okay, profit or utility. So, and then he cannot carry within certain limit. So there is carrying capacity C. So the question is simple: which object should he bring to maximize his benefit? This is exactly the same as prioritization above. You can try. You can try to consider the interconnectivities of the activities. So in this example of knapsack, okay, so there is no interconnectivity between tasks. Okay, so all independent. That's the assumption. So let's go to the mathematics of that. So you have value V, okay, and then you have a variable that you want to decide, xi. Okay, and then you have weight for each items that you want. Okay, you have weight. So this is the cost, the effort. V is the value that you set. Okay, and then C is the total time. So if W here is the cost for the time, so this is the total time. This is the carrying weight capacity. And X is practically just a binary numbers, 0 or 1. Okay, so what you have V, the values, you have the cost, the W, and you have the capacity threshold. And then you want to find yes or no to be included or not included. That's why it's 0 and 1. So, okay. So, knapsack problem or KP is one of the simplest but non-trivial integer programming. Yeah. So with binary variables and only single constraint, yeah, and only positive coefficient. Yeah. So no negative values. Okay. And actually, this is a very difficult problem. Yes, it is linear programming. Okay, that's correct. Yeah, not so. It is actually a linear program. That's correct. Okay. So this is what we can do. So I created add-ins from based on that. Very simple. Okay. I can create activities. Okay, based on that a while ago. The value, and then we can put the values, maximum effort, and then it can calculate automatically. So I can table for you. Let me demonstrate it to you. Let me go to Excel. So I will create a new sheet here. Okay, and then the name is antecedent. So I generate new example. So say you have 9 activities, and these are the hours, and these are the values. Okay, and then I want to prioritize this. Yeah. Oops, we still have a problem. Okay, so using we can prioritize. Yeah. There. This is the result. Okay, so what happened is it will choose to prioritize. Yeah, and this is the total value become 31. Okay, with the criteria of maximum effort of 7 hours in here. Okay, and then this will not be used. Yeah, these activities will not be put into consideration, and it will prioritize C first, and then E and F and D. So you can do this in Excel. Yeah, without add-ins, you can use solver. Yeah, exactly the same thing. Okay, so this is what you will do in Excel solver. Okay, let's practice this in Excel solver. Okay, you want to hide, and you want to carry only 9 kilo, and you have 5 items. Okay, so then the question is which particular value you will bring. Yeah, you have only A, B, C, D, E, and carrying capacity is only 9 kilogram, and these are the kilograms, and these are the value that you want to put in. Okay? So how to put it in Excel? Okay, this is what you will do. Yeah, you put this value at 386 in this W. Okay, so the weight, right, and then the value from this problem 2, 12, 9, 3, and so on. So you put it in this column. Okay, and you have the budget of 9. Correct? And then what you will do is initially you put all 1. This is the XI. Is it clear? And then what you will do, you multiply. Yeah? This value of WI multiplied by XI. So 3 times 1 is 3, right? And then this one is VI times XI. So this means 2 multiplied by 1 should become 2. Is it clear? So initially you have these values. You can also put it 0 if you want. That's okay. But 1 is probably easier to see. Because if you put 0, you will not see the actual value, whether you multiply correctly or not. Right? And then what you will do, you set up solver. Yeah? Excel have solver. Okay, and this is what you will do. Yeah, you set the objective to be the total value here. The total value is this 31 here, the green one. Okay, and then you maximize this. Okay, and then what you will do, you will change the variables. What is this one? The yellow is XI. Is that okay? Okay, and then the total cost, okay, should be less than the budget. And the total cost is this one, 23. This 23 must be less than this one, budget. 9. Okay. And then you just put this xi to be binary. So you add here and then you change to binary. Okay. So this one, check. This is the solving method. And then just click solve. Yeah. When you click solve, you will get this result. Yeah. Okay, see, within the budget. Yeah. So less than 9. And this is the result. Yeah. 1 and 1. That means you do C and E. Okay. So if this is represent the stocks, yeah, and the expected return from the stocks, so then you can also check, okay, which stock you should buy. Okay. So if this is represent the project, then which project you should use, yeah, within your budget that you have. Okay. So this is exactly what you're doing using knapsack. So up to here, is there any question?
Hi, sir. May I confirm if the antecedents add-in will be provided to us, or
No.
we're just gonna...
You just do using a software.
Okay. Thank you, sir.
Honestly, they're not provided to you.
So question, is there a manual way to solve without using solver?
Super difficult.
Hmm.
Because the algorithm of this is using integer programming. So, the one that I'm doing manual way is exactly the sequence of strategy 1 to 6.
Okay.
Okay. Okay, that's what I did earlier. Before I know knapsack, okay, I'm doing it manual way. Okay, and then what happened? I was believing that this strategy 6 is the most optimum one. Okay, with this dipping 27 in this case. So, and then I start to think, oh, this is the best one. No other way to be better than this. And then I encounter this OR, operation research or management science technique called knapsack, and then I try. Okay, and to my surprise, it gives real optimum. It is 29. Then I couldn't believe that it beat me. Yeah, in my own strategies. Yeah, so that means yes, the mathematics is really very powerful. Yeah, so yes, you need software with this solver. You can anyway. If you have Excel, you can use solver. If you don't have Excel, you can use Google spreadsheet. There is also add-ons that you can use similar to solver, and it's free. Right? So using this, you can apply to many other application, in your case. So you can prioritize based on, of course, the criteria is only 2. Yeah, it is only cost and value. Yeah. So anything to discuss? Any question about this? So say you have certain capital, and for the stock investment, and you have, of course, the cost for stock and then potential return for investment. You can also do that. Okay? And yeah, this is exactly the same thing. So you can also use risk. Yeah? This is also put this as a risk, as implicit in the net return. Yeah? So this is another practice. If you want, you can practice this. Okay. Say you have $10,000, and then these are the cost per stocks, and this is the expected return. Of course, this is based on the historical values. Okay, and how many stocks that you should buy in each investment. So, what's the difference? This one with the earlier. And earlier is 0 and 1. Okay, in this example, the X is not 0 and 1. Can you see the difference? The X here is how many stocks should I buy? So that means this is not 0 and 1. In the past, a while ago, is 0 and 1. That should, in the project, you are telling about, should I put it yes, should do this project or not doing this project? So 0 and 1, binary. Okay. So in the stock example, this is how many stocks, that means integer stocks that you need to. So initial setup, you will do this. Okay. Again, this is come from the value given. Yeah, stocks and these are the weight and these are the value. Okay. So this one, copy. And then initially you can put either 0 or value, any value, 1. Okay, the budget is given. So you do the same thing, yeah? You do total value, xi, so exactly. The only difference is here. Xi is now not binary, but integer value. Okay. Then you will get this value. Oh, interesting. So it doesn't give suggestion to buy A and B or E. Yeah? It gives suggestion optimize within your budget, which is 10,000. Okay, to buy this how much? Yeah, 4 stock of this and 31 of this. Yeah, this will give you the yield. It is the most optimal things. Is this something interest you or not? I don't know. So of course you can apply this to logistics. So yeah, say you want to dispatch, or imagine this is not the airline but the bus. You can also do that, right? So you want to dispatch of the cargo airline to decide how many load the package, yeah, to particular plane. Okay. Now each package have certain weight and certain plane. Okay. Will have certain maximum capacity. Okay. So now the question is now depending on the arrangement with every customer. Okay. Then you can set a rate per weight, unit charge per request. So in that case, now you can put the profit as your goal if you want. Yeah. Oh, you did it. Okay. Super. Yeah. Pin Sanchez, we can go in the course. Yeah. Also, Rafi. Yeah. So you are expert in Excel already. So I guess this is nice. Very nice. Okay. So you can also apply to production. Yeah. So say sawmill want to cut the log to the shorter pieces, and each pieces, however, need to be cut into standard length. Okay. So you have a few standard length in this case, and its length associated with certain selling price. Then again, you can use the knapsack problem to formulate, yeah, how many should you put in the cutting of each standard length, yeah, in order to maximize your profit. Okay, you can also apply to academic and so on. Okay, so again, students will receive n question in certain way, indicate the points of the question. Okay, and you have you can select subset of a given question, and then okay, after the exam, all the questions are answered are graded by the instructor, which assign certain points, right? So in that case, you want to know, okay, what is the best possible mark, okay, for that. Can be chosen automatically. Okay, for the transport project, you can prioritize based on benefit, cost, and impact, right? So again, you define the evaluation criteria. Okay, then you can collect the data and you set the weight, the score, and then you calculate the score, say using MCPM or ALCO, and then you run and adjust the project. Okay, so simple as that. So usually a transport project is much simpler, but if you want, you can use this earlier, yeah, knapsack problem. Yeah. So if you know the cost and benefit, so these are the represent the cost and this represent the benefit, and you have certain budget for your costs, then you can use this technique also. Yeah. Okay, with this, yeah, the rest you can just read by yourself. These are just descriptive about what is the qualitative factors and so on, okay, that you can include. So basically the factors need to be qualitative and quantitative. Okay, then you can balance to get the distance. Okay. And then you need to put the weight. Okay. The weight can be set subjectively, okay? But if you use IFN later and IFN prioritization, the weight actually can be computed based on data. Okay. After that, you calculate the score, okay, and then you can calculate the total score and put the rank, yeah, similar to the usual multi-criteria decision making. Okay. Once you make that, okay, then of course you will review the ranking. Yeah? Is this really what you want or not? Okay? So if not, then you make necessary adjustment. You probably change the factors, the weight, probably the scoring that you set there. Okay. So again, the mathematics is just simple. Yeah, you set the criteria, you put the alternative project and the scoring. Okay, and the question is whether you see certain rank reversal or not in your projects. Okay, later on, task. Okay, so with this, I hope we have enough for the day. Because, yeah, because the next topic is MCDM, so please read beforehand. It's not so difficult. Okay, probably the most difficult part is the normalization. So there is also text about normalization there that you can read. Okay, for next week. And for your group project next week, can you present in a group? So please give me an update on your group project next week. You can combine your power dynamic individual to your group project. That's also fine to make it more efficient. Okay. So let's discuss. We have a few minutes for discussion. So anything to discuss about this introduction to prioritization? Or give me feedback so that I will know what did you learn? Okay, anything to improve? Yes, Ray.
Sir, I just have a question, but I think it got answered eventually during the end of your lecture. Because when you were discussing the knapsack problem, I was thinking, how does it take into account perhaps a water bottle, which a water bottle at the beginning of your hike, it will be full and it has a certain weight, but eventually during your hike, you will be drinking water and it will lose weight eventually. So it makes your backpack lighter. So, but when you when you ended your lecture about prioritization, and then you mentioned about some other qualitative factors that you take into account. I guess that answers my question about
This is actually about planning, right?
Yeah.
So the one that you put into consideration of that the water bottle will be reduced along the way. Okay, that is about the execution, implementation already. So okay, so knapsack is very useful for planning. before you go the trip. Okay, so if you take that into consideration, that the water bottle will be reduced along the way, then you probably want to increase your capacity. That you can carry certain weight, not 9 kilo, probably you can carry 12 kilo, but you know that along the way you will reduce anyway. Okay, so
Yeah. Thank you, sir. It was just something I was thinking
Yeah,
about when you were there.
I think
Yeah.
that's creative thinking that you have done. Thank you. Yeah. So try to do this, okay, and let's do this as a practice so that you can start to see that you can prioritize and try the 6 strategies above manually, and then try to use the knapsack. Okay, then you can start to see the actual power of optimization. Okay, it is interesting. Because if you just put any numbers without actually trying different strategies, you don't really see. If you don't do it manually, you don't really see. You don't really appreciate the optimization. Okay, put that optimization as the last part of your computation. Try to do it manually first. Okay, once you do it manually and then you think that this is the best, then try to use knapsack. Okay? And then you start to see whether your manual strategy is actually better than knapsack or not. Okay? Mathematical guarantee that knapsack will be the best. Okay? But who knows? Maybe you have better strategy. We don't know, right? So you can try. This is a challenge. Okay. Interesting enough, I hope. So let's meet again next week with your first presentation of your group projects, yeah, and then we continue with MCDM. Knapsack calculator. Knapsack calculator is using solver here. Okay, knapsack calculator using solver. Okay.
All right. Thank you, Doc Kardi. Yeah.
So if you really cannot do so, then I will help you. But at this point, let's try it. You try first, okay? So thank you. So see you next week then.
Thank you, sir.
Thank
Thank you,
you,
sir.
sir.
Hardy.
Thank you, sir.
Thank you.